No! Oh, okay.
Next chapter. I know. All right, law of cosines.
I hate graphing and word problems. Those are the devil's work.
Okay, if you have a pair of angle side values, that's how you know that you're going to use the law of sines that we've been working on for the last couple days. So then, of course, you need something for when you don't. If you don't have a pair, you can't figure it out a pair, then you need a backup. And so that's going to be today and tomorrow, where you have no pair of angle or side values. And so then that's the law of cosines. Ooh, where'd it go? There it is. All right. So, no word problems. It's just straight math today, just working through practicing the law. So here's how the law of cosines goes. A squared plus b squared. So it's kind of looking familiar to what? Yeah, Pythagorean theorem so far, but we know it's not Pythagorean theorem because Pythagorean theorem only works on what kind of triangles? Right, and these aren't right triangles. So it's a squared plus b squared minus c squared. Okay, over 2ab.
That's it.
Okay, it's like all, remember in quadratic formula it was like all over 2a, now it's nb. Okay, got to add that. No, not under square root. All right, and that is equal to the cosine of c. Okay, that is called the law of cosines, but it only works for cosine c. So what do you do if you have cosine b? Okay, no, don't get that. All right, well, here's how you do cosine b. It'll be a squared plus c squared minus b squared. Okay, all over 2a and what other letter? C, correct? And that's going to be equal to cosine b. So the subtraction part always has to match the cosine part, right? So if you're subtracting c squared, that's cosine c. If you're subtracting b squared, that's cosine b. So of course, you should be able to do the third version. Does anybody want to try it? Okay, go KP. You got it. B squared plus c squared minus a squared all over 2b and c, and that's going to be equal to cosine a. Right. So there's a definite pattern to it. Just make sure you match the subtraction part to the cosine part. Okay, these are called the laws of cosines. And this is what you do when you don't have a pair. All right, so let's practice. So since we're not doing word problems, we're not going to draw bearing or trees or hills or buildings or anything. I'm just going to give you your 6 parts. So A, B, C, and A, B, C. Reminds me of the Jackson 5. A, B, C, easiest one. Okay, all right, here we go. 14, 19, 8. So clearly no pair. All I gave you is 3 sides. This is side, 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 SSS. So clearly no pair. So we need to start with one of the law of cosines. It doesn't matter which one you start with. You could say I want to start with A, or I want to start with B, or I want to start with C. It's irrelevant which one you start with. You can just pick. So does anybody have a favorite letter they want to start with? A. All right, if we're going to do A, then what's the order? If we want cosine A, then how does it go on the other side if the A is what we want? Then where does A have to show up in the fraction part? A has to be the subtraction part. If you're going to do the A part, then A has to be the subtraction, and it's going to be B squared plus C squared and 2BC. So that's the only thing you got to keep straight, is depending on the angle that you pick, make sure your subtraction is right. Okay, so we can plug in 14 squared plus, oops, my fault, 19 squared plus 8 squared, 8. Okay, minus 14 squared, all over 2BC. So that's 2 times 14, did it again, times 19. Now I've got hand on my, okay, 8. And that equals cosine. So what you want to do is figure out what 19 squared, 8 squared, and 14 squared works out to be in the numerator. And figure out what 2 and 19 and 8 work out to be in the denominator. So you've got some workable numbers. Does anybody happen to have the numerator figured out? Say it again. Okay. And then how about the denominator? Okay. All right. So we're trying to find A. So what should we do to both sides to get A by itself? Inverse, exactly. So we will set up the inverse. So A is going to be the cos inverse of 229, 304. And I've got, according to my calculations, somebody should verify this for me, a little more than 41 degrees. Okay, so A turns out to be 41.124. All right, so I'm going to go back to my list of my 6 things, and I'm going to put in 41.124 degrees. So that wasn't so bad. Okay, now we'll do it again. Pick a different one. So we've got B or C left. And so you just decide what you're going to do. She wants B, okay? All right, so let's do B this time. So if we're going to do cos B, then we've got to make sure that in our fraction, the minus part is the B part. So that would be A squared plus C squared minus B squared over 2AC. So the order for that would be 14 squared plus 8 squared minus 19 squared over 2 times 14 times 8. And that's equal to cos B. And so then you figure out what your numerator is, and you figure out what your denominator is, and we'll go from there. All right, anybody got a numerator? 14 squared.
Is it a number?
Yeah, it can come out to be negative, or negative 101. Okay, and then how about a denominator? 2 times 14 is 8. Okay, and then we'll apply inverse cosine to that on both sides. So the inverse cosine of the negative 101 over 224, and that should tell us what B is. So according to mine, I've got I got 116.801. So then I'll go back up to my list of 6, and I'll insert in there 116.801 degrees. Now, do I need the law of cosines a third time?
No.
Why not? I can just do the rule of 180. So I can do some easy subtraction, and I can come up with the rule of 180, which tells me that's got to be 22,075. So that's how the law of cosines works in a situation where you have side, side, side. Now we're going to have some other different situations, so I'm going to show you another one. But that would be one example. Any questions on that so far? Okay, let me give you a different combination. It just still won't have a pair. All right, AB's are different side angle. Let's see. A is 115 degrees. Side B is just 15 degrees, and side C is 10. So again, no pair. But it's sort of chosen for you which law you're going to use based on what you're given. Because you're given angle A, you got to start with the angle A law of cosine. So we're going to start with that one. So it'll be the one where cosine of A is equal to B squared plus C squared minus A squared all over 2BC. All right, we're going to plug in. So we're going to have 15 squared plus 10 squared minus A squared over 2 times 15 times 10 equals cos of 115. Now I won't be able to get a complete numerator this time because I don't have all three of the numbers. So I'll only be able to do the 15 squared and the 10 squared part, which is fine. 15 squared is 225, 10 squared is 100. So I'm going to have 325, but I still have a minus A squared because I wasn't able to figure that out. Over, and now I can do 2 times 15, which is 30, times over 300 equals cos of 115. Now I'm not going to use inverse this time because I want to get A by itself. So what kind of problem does this look like? It is. I'm going to drop a 1 under here, and I'm going to cross multiply. Cross multiplying by 1 is easy. Okay, so I'll cross multiply by 1, and I'll cross multiply the other way. So I'll have 325 minus A squared equals 300 times cos 115. Now what do I do to both sides? I'm trying to get A by itself. Subtract how much? Subtract 325. So that'll be minus A squared equals 300 cos 115 minus 325. Now I can't subtract 300 and 325 because the 300 has a cosine on it and the 325 is just plain, so I just leave it like that. Don't turn it into a decimal because then you'll round and you don't want to do that, just leave it. Okay, I'm trying to get this by itself, so what do I do next? Can't square root when a problem has a negative in front of it. So I got to divide by -1 first. So then I'll be able to do a square root. So that when I divide by -1, the 300 becomes the negative part, and the 325 becomes positive. Now I can use a square root, and what goes in front of a square root? Okay, so plus or minus the long square root of a -300 cos 115 plus 325. And now you type that whole thing into your calculator to get the decimal. And so you're going to get plus or minus 21,255. Now there will probably be an instruction that says all your sides have to be positive, so we're only going to list the positive 21,255. Now it's your choice between angle B and angle C.
What are the units? Are there still units on the
In a word problem, yeah, this would be feet or miles or meters or whatever because it's the side of something, but in a non-word problem, there's no units, yeah. oh, could you switch back to the law of sines now that you have a that you have a pair? Okay, you can. Your answer will be, because you're using a rounded answer, the 21,255 in the law of sines, and you're changing signs. Your accuracy is gonna be off by a little bit more. Like, you will have lost accuracy. So I usually recommend, once you've done one part of it with the law of cosines, to stick with the law of cosines. That's my best recommendation. You would be really close. So if it was like a multiple choice, you'd probably be able to find the right answer. But if we were grading by accuracy to the thousandth decimal place, yours would be off by a couple thousandths. So if you wanted to do that, you'd have to have more accuracy in your yellow number. I'd need you to go longer. So I'm just going to say my best advice is to stick with the law of cosines. But you can choose B or C, whichever one you want. So we'll just do B because it's in order. So if I'm going to now do cos B. Oops. And so if I'm doing cos B, then the minus part has to be the B squared part. So it'll be A squared plus C squared over 2AC. So now I will have 21,255 squared plus 10 squared minus 15 squared over 2 times 21,255 times 10 equals cos B. And so you should be able to get a whole numerator and a whole denominator at this point, and then use your inverse on both sides. And try and be as accurate as possible. Use as many decimals as you can to improve the accuracy. So you need to come up with a numerator. Does anybody have that? I forgot to write it down. I just had the final answer. Okay, I'll confirm. 320, I got 326. Yeah, 326,775. And then divided by your denominator. Oops. I get 425.1. And then you can apply the inverse cosine on both sides of that. So 326,775 over 425.1, and then you should have the value for B. I got 39.763. And what are the units on that? Yeah. Okay, so then I'll go back up to my 6, and we'll have 39.763 degrees. And then you don't need to do another, you only have to do a law twice, because the last time you'll just use the rule of 180 to complete that. So that's going to be 25,237.